So despite saying that I want to just start with some examples, I will give you just kind of a too long didn't watch explanation of my take on Notebook Assistant. I think at this point we're all familiar with ChatGPT, and I would say that Notebook Assistant is like a custom version of ChatGPT that has access to all of our documentation and all of the data that makes, say, Wolfram Alpha so powerful. It knows, all of the functions in Wolfram language. And if you go to the documentation, you can see that there are over 6,300 as of the most recent release functions. That's quite a large number. It's nice to have a computational assistant for that. It knows about all the tutorials, all the examples. And like I said, it has access to all the data that powers Wolfram Alpha. It can improve your code. It can explain code that you got from somebody else. And as is the primary focus of this talk here, it can turn your rough ideas into computation. So Notebook Assistant, in summary, works like a hyper smart, fully knowledgeable helper that lives right next to or inside of. You can open chat cells in a notebook just by typing an apostrophe. It just lives next to your notebook or inside your notebook. And if you want to use Notebook Assistant, you can sign up for Notebook Assistant and LLM Kit. And there's no configuration necessary. As soon as you kind of sign in to activate your product, it's all linked to your account and everything will just work. So let me show you some examples. We'll start kind of simple. Say I'm brand new to Wolfram language and I want to know how to do kind of a basic programming task. Let me say something like, let's say, how could I find the running maximum of a list? Actually bump the magnification here. It's a little bit small at 150 on this monitor. Maybe that's better for folks. And then I can just press enter. This gets sent to the assistant. And this gives us a nice little answer here. So in Wolfram language, we can use the fold list function. And here's an example of how this would work if we had some sort of list. And here, note that the function here is linked. So if I click this has actually opened up the documentation page so I can read all about this particular function that the assistant has linked. So here it gives us an example of this running. And then it also notes, and I think this is kind of a neat thing, that this has access to this through our documentation, that you can use this resource function that kind of automatically does the task that we've asked it to do. Resource functions kind of extend the functionality of Wolfram language. The way I always put it is, if you think 6,300 built-in symbols and functions isn't enough, if there's like some specific thing you find yourself doing really frequently, and you think maybe somebody else might like to use that, we have this thing called the function repository, where users and people from Wolfram here, we can all submit functions to the function repository, and then everybody can access them after they've been approved by us. And this will just grab the function right from the cloud, and we can just use it right in the notebook. Now, Notebook Assistant gives us this answer, and it gives us this code. And something that's quite useful is you'll notice that not only can we copy the code, we can insert and evaluate the code here. So if we click this, we get this, and we can see that indeed for this example list that it has come up with, at first, the largest element is 3, starts at 3, and then it stays at 3, and then 5, 7, and then once it hits 8, we stay at 8 because 8 is the largest entry. 7 isn't larger, 5 isn't larger. Once we hit 9, we stay at 9 because 9 is the largest entry. And there we go. So that kind of does what we'd like. Maybe we have an image in our notebook. So let's say we've got some cats. We'll just call it that. If you're new to Wolfram Notebooks, for reference, you can just copy and paste images right in here. You can also use the import function or drag and drop things from your file explorer. All of that stuff just works transparently. And once it's in the notebook, it's a fully computable object that you can do whatever you want with. It's really, really, really useful and nice for folks who do image analysis in particular, but it's also nice for, a hobbyist. And again, I've been in both of those positions. I've done some image analysis for things in a lab in grad school and just on my own. And I have a little example coming up to show you that. But now that I've got this cats here, I could say something like, how could I find where the cats are in the image cats? So here, it asks us to do this. And it tells us this is this function that could be used for this. This is actually, this is not something I was aware of. This is a new one. And so we go in here, it's giving us coordinates for where the cats are located in the image. There are a couple of different ways you could go about that. And, I'm going to ask and see if it's willing to suggest to us a different way, maybe. So two things to kind of notice here that I'm doing, again, a bit transparently. I ask, is there any other function that could do that? And it knows that I'm referring to this previous chat here and what we have in the notebook. So the Notebook Assistant is aware of the whole chat history above it, and it's aware of everything that's in the notebook over here that it's focusing on. And how can you choose which notebook to focus on? Right here, if you just click this, you can choose any notebook you have open. You can see I'm currently in the middle of Neural Nets Bootcamp as well. And you can also just have it choose automatically, which is the default. And what that will do is it will just focus on whichever the last notebook is that you've clicked on. So let me click this. Any other function that could do that? Yeah, so you could use image contents perhaps. And then here we get a nice little data set where it says, okay, we've looked in the image of that I've called cats here. There's nothing special about calling it cats. It's just what I've called it. And we're able to see, oh, okay, there's a domestic cat, and this is the little thumbnail, and another domestic cat, and this is the little thumbnail. And here are the rectangles that are the bounding boxes for these cats. And here are the confidences that this thing has, that this thing is a domestic cat in each case. So that's pretty nice, if you ask me. You can also ask kind of questions that are a little more, let's say, Wolfram-y in a way. Questions that take advantage of kind of the curated tower of knowledge on which Wolfram Language rests. And you'll see what I mean by that when I ask, how could I make a 3D plot of the terrain around a mountain? Okay, so it's letting us know about these functions. Here's the thing. As an LLM-based thing, sometimes Notebook Assistant will hallucinate. I found it's actually quite good about not doing that. It really knows when to use Wolfram Language and the Wolfram Entity Framework to get real hand-curated information rather than just crawling the web or using training data or using information that was in the training data. But even in the cases where it might hallucinate, you still get links to useful functions that you can check out. And so even if you can't quite get it to work, this is always a good starting place. But let's see if this did work. So let's just insert and evaluate this here. And that works, no question. So here we can see that we have used the geo-elevation data function here to get Mount Everest as kind of our center point. And then we're kind of looking at a 4-kilometer block around this. That's going to be our data. And then here, it has put that data into a list plot 3D. This is a function you can use to plot a list, which is a Wolfram Language generalization of an array. And here, it just plugs it in, and it even cleverly, I do think this is actually quite clever, is it uses the mesh functions option and then specifies, this is kind of a pure function notation. It's like a lambda function if you're familiar with that. If you're not familiar about it, don't worry about it. It's not a big deal. You can always check the documentation if you're curious. But what this mesh function does is it's getting the third coordinate. That is, we think about the X, Y, and Z coordinates in a sense. It's getting the third coordinate and it's drawing nice mesh lines on there. And it's doing that because contextually it's aware that if you kind of want to look at elevation data, you often want to have these lines that indicate how high up you are, these lines of constant elevation. And that can give you a sense of how rapidly the topography is changing. So here we see it's very steep. We see a bunch of lines gathered together, whereas here the topography isn't changing too much. The elevation is pretty constant, so we don't see too many contours there in a sense. And now Because the Notebook Assistant is aware of the previous conversation and of what's in the notebook, I can say things like, oh, that's great. People go back and forth on this, but I have tended to notice that when you're dealing with an LLM, being polite does get you generally slightly better results. This might sound a little bit kooky, but if you think about the way LLMs are trained, right, they're trained on a bunch of training data. And generally, in the training data, when you have somebody kind of politely asking a question or having a conversation, the responses to somebody being polite are going to tend to be a little bit better. So let's say, oh, that's great. Could you make it so the color of the plot depends on the height? Okay, so it gives us some new code here. And if we just insert and evaluate this, we get indeed exactly what we wanted. We can see that we've got a rainbow color scheme here that was just kind of the default that was picked for this. You can ask for other color schemes if you know about them, or if you kind of want to just get roughly close to like an idea of a color scheme you have. But there we go. We're able to pull in this geographic information through the geo-elevation data function. And we're able to pull in all this surrounding information about, what is Mount Everest? Where does it exist exactly? What are its geo coordinates? All that stuff just happens transparently in Wolfram Language. And then it's even easier here because you don't even have to have known about this stuff. You can then just ask Notebook Assistant, and not only does it do it for you, but because it provides the code, you can look and you can start to get a sense of like, oh, this is pretty neat. I bet if I put in, another mountain here, let's say, is that right? Is that how we think about that? Then I could run this again. And here it is for K2, different mountain. It's actually quite interesting the way that looks there. Maybe if we have any volcanologists in the audience, they know exactly why it looks like that. But to me, a layperson with respect to mountains, which is not a sentence I find myself saying frequently, I think that's quite interesting topographically. So that's just kind of a little example of being able to write code that pulls in functions that use real curated data that we have access to through Wolfram Language. Can maybe take a step back and do something maybe a little simpler in a sense. Maybe you were working with some graphs, not graphs in the sense of like the plots of a function, but graphs in the sense of like a network. So maybe I have a graph and I want to swap the nodes and edges. I can just ask about it. Okay, so it suggests using the line graph function. And then it comes up with some example code. So suppose we have this original graph. We can then swap the nodes and edges by using this. And if we click on here, let's go ahead and not suppress. A semicolon suppresses output. So we're going to leave the original output of the original graph. We're going to see that this is the original graph, and this is the graph with the nodes and edges swapped. So now not only do we get a result, but again, we can see an explanation for what the code is doing, and we get to learn about the function line graph. And again, if we click that, it pulls the documentation right up. And again, for folks who are newer to Wolfram Language in particular, there is something I want to note about the documentation. Well, a couple things really. One, the documentation is really good. We spent a lot of time making sure that it's very thorough, has a lot of useful examples and details, even things like neat examples. But maybe more relevant to the Notebook Assistant is maybe it gives you a function and it's really close to what you're asking for, and you can't quite figure out how to ask for exactly what you want. What you should do is you should just click on that function name, come to the documentation here, and look at See Also. And in many cases, if the function that was suggested isn't quite the one you want, you'll be able to find the one you want and See Also here. So you could click in here and say, oh, okay. well, this is what I wanted. I actually wanted to get the graph complement here, which does this. And then you can look at all the examples, and maybe this one isn't quite what you want. Maybe you say, oh, I wanted the graph intersection or something like that. And it's all just there in the documentation. And if you have any questions about anything in the documentation, guess what? You can ask Notebook Assistant about it. We can do things like, suppose that I've got a CSV file and I need to make a plot. Well, that's a very common use case in my experience. So it might be something where, again, if you're new, you might not know how to do it. So you could say, how could I make a plot from a CSV file? Okay, so it gives us kind of all the steps. We should use the import function to read the data from the file, and then use a plotting function like listplot or datelistplot. Importantly, not just the plot function, which plots functions rather than data, but listplot and datelistplot, which are what we want for a CSV. We can use those, and there we go. And here it gives us, how do we import something? And then it says, here's how you would plot it. And here, it does specify we would want to change the path to this. Let's see. I don't know if this will work, but let's give it a shot. So here, it gives us some fake data. And not only that, it tells us how we can actually generate the fake data. So let's insert and evaluate that. There we've got data. Dataset has a lot of functions. I don't want to get into it here, but oftentimes we use dataset as kind of a wrapper for, say, a nested list or a list of associations, which is kind of like a dictionary or a lookup table, very common for using a dataset. But here we just want to take the random data. So here's data. And let's see, this isn't going to work, but we'll run it here, and it doesn't do quite what we wanted. So let's say it looks like this data. So you can kind of have this kind of back and forth conversation about getting exactly what you want with the Notebook Assistant. So if we look at each row again from the data set here, we see that there are letters, and the letters are preventing listplot from working the way we might expect it would. So what we're going to do is we're going to ask, how do we get rid of them? Not work, yeah, not work quite correctly. How could I remove those letters so that I could make a standard scatter plot? Okay, and this gives us exactly what we want. It refers to the actual variable that already exists in the notebook in its code here. And it says, basically, if we go to all of the rows and get the second through the third columns, then we'll be left with just numerical data. And indeed, that's precisely what happens. And I did put this a little bit out of order. My cursor was up there. But we insert it, and we get exactly what we want. So that's pretty neat. You can ask kind of more jargony technical questions like make a Bode plot for a Butterworth filter. And because it's jargony, we should put the appropriate respect on these things and give them a capital B. Okay, so this gives us a little example here. Let's give it a shot. And there's that. And from this code, we can see that this has picked a particular plot layout. And then, you can allow your natural curiosity to take over and say things like, well, what if I don't specify anything for the plot layout? Let me just remove this. Doesn't take a lot of coding knowledge to just, try removing things and seeing what happens. What can go wrong, right? And there we can see that this has both is it a magnitude and a phase? Maybe in here it will say magnitude and phase of the transfer function. Okay. So magnitude and phase we can get by removing that thing. And then this is for a low pass. And so we could say, you might be able to guess what we should replace this with if we want a high pass version, but might as well ask Notebook Assistant just to check, just see what it says. Okay, so here we go. We got a little explanation. Indeed, you just type high pass, and then here in the bode plot, it has gotten rid of what it used to have, where it specified that the plot layout should be only magnitude. So let's just insert and evaluate it, and we can see the different behavior of the low pass filter and the high pass filter here in both the magnitude and phase spaces. And something that I have to say I think is quite nice is that it has kindly included automatic grid lines here. And you might say, oh, well, that's not a big deal. Who cares about grid lines? Well, thing is, at a glance, let's say you're not the most observant person, or you're just looking quickly, right? You might not notice the log scaling on this axis. So the grid lines serve as a nice reminder that the default way that bode plot works is to use log scaling. Because generally in Wolfram language, right, you make a plot of some data or a function. It's not going to be log scaled unless you ask for it specifically. But for bode plot, it is log scaled. And then we have these grid lines here that can kind of remind us of that. So we've got these grid lines that compress in this direction, but not in this direction, which is characteristic of having a log scale on this axis, but just linear scaling on this axis. So I think that that's quite nice, I have to say. So we've got knowledge about things like, different types of filters and different types of plots. And, we talked about some like geo-elevation data, but there's also socioeconomic data available through the Wolfram Entity Framework, which is, again, that's what powers Wolfram Alpha. When you ask it a question about the world, it uses Wolfram Language, and it uses the Entity Framework to pull data and use that in its computation to give you an answer to your question. And something I really want to make clear here, I said this before, but I want to make it really clear, especially in the context of LLMs, is, when you train an LLM, it has its training data, right? And if you ask questions about certain facts to an LLM, not even say like a mathematical computation, but if you ask it about like the population of a country, oftentimes you'll get information that's a little bit out of date because the training data for the model you're using is maybe a couple months old, and maybe it's got information that's older than that in there too. So in here, kind of something that's special is that through the access to our entity framework, the Notebook Assistant is able to have access to actual hand-curated data that we have a team here at Wolfram that actually takes this stuff by hand and is updating the entity framework with this. It's not something that we scrape from the internet randomly. It's not something that's baked into the training data. It's something that we actually have in our own hand-curated framework database thing. So it's useful to know about this. So we could ask questions like, what's the height distribution of American 10-year-olds? And we'll see if it can get this. So apparently there's a human growth data function, which I did not know about until trying this query out earlier. So we'll just take this, we will insert it, just see if it works. Okay, so we get a normal distribution for each one of these. They have slightly different means and variances, but they're pretty close for the male and female height distributions at age 10 years. I'd like to get like some histograms or something, you know? And here we see the first explicit case of something else that Notebook Assistant can do. It can directly access not just the information in the entity framework that Wolfram Alpha uses, it can run its own Wolfram language code and produce results in here for you. Like you don't even have to click insert and evaluate necessarily. So here we get some nice stereotypically colored probability distributions for height. And if we click on this part where it says use Wolfram Language Evaluator, we can see what the code was that it used, and we can copy it or insert and evaluate it just like usual. Close that. And I could say, oh, those are pretty close together. Could you update this for, let's say, 17-year-olds? And again, it's taking the exact code that it's written and actually evaluating it here for us. And now we can see that once puberty has taken root, there is a much larger difference in the height distributions here. So I think that that is pretty neatly done, if you ask me. And on the note of, say, sociological or socioeconomic data, excuse me for a second, I'm going to adjust my curtain. The sun in its inexorable move across the sky has started shining directly into my eye. So let's ask another one here, sociological. Let's say, show me a plot of Asia where each country is colored according to its total population. Okay, this suggests using the geo-region value plot function, which I think is quite a nice way of doing this. It's what I would consider kind of a natural Wolfram language way of doing this. So let's just insert and evaluate, see if it works. And there we go. There's a plot of Asia according to its population, and we can see that this is a pretty polarized distribution in a sense. It's pretty bimodal. So that is interesting enough. And here, this teaches you something about using Wolfram language. And it says, hey, in the future, you can use geo-region value plot to plot some geographic region where you've got some geographic areas, and then they each have a corresponding value. It's just like it says in a geo-region and a value, and you plot it. So Wolfram language's intuitive naming coming to the fore yet again. You can also ask questions, again, if we return to the idea of kind of asking code questions, if you really don't know how to do something, you can ask not just how to do something, but you could ask for maybe a few different ways to do it. So you could say something like, show me a few different ways of, let's say, making a list where all the prime numbers are framed. And let's see if it does indeed give us a few different ways of making such a list. Okay, one way is to use table and if. Okay, if prime q, so this is going to test if its input is prime, then it's framed. And if it's not framed. So let's try it. There we go, that works. Using map and if, that's another way to do it. So this is kind of like, it's a little more procedural perhaps. Table, you specify some sort of function here. It can be anything. And then you can specify an iterator and bounds. Here, if you don't specify that it's starting at 1, it's just going to assume you start at 1 and go up to 20. We could use map and if. This is a little bit more Wolfram languagey. And here, you can see this produces the same exact result. This uses the aforementioned pure functions. You don't have to get into exactly how this works, but the basic idea is that we have a function, and the function says if, and then this thing here is called a slot, and it just says if the input that's coming into this, it's filling in this input slot, if it's prime, frame it. Otherwise, just return it unchanged. And then we're going to take that operation and we're going to basically distribute it via map over the range 20. So just for what it's worth, map, let's say range 20, that does that. And then this function here, if you feed it a prime number, it will frame it. If you feed it a composite number, it will not frame it. And so our f here is this, and it's just doing this. And here's another way that uses replace. And this is maybe the most Wolfram languagey way. There are, again, other ways to do this. But here's this. And this is kind of nice. You start off with your list. You just start off with it right in the beginning. And then you use this operator, which just means replace all. It's going to look on the left side here. And then on the right-hand side, you can specify a pattern. And so again, it's a little beyond the scope of what this talk is supposed to be about. But the idea here is we're going to look for any one thing. We're going to call our one thing, if we find it, n. So that would be like a 1 or a 2 or a 3. It's just any one thing. And then this is a shorthand for a conditional operator. If you're a mathematician, perchance, we got a lot of academics. We probably have a couple mathematicians. You can think of this as like a such that. So this is find any one thing, call it n so we can talk about it later, such that n is prime. If you should find such a thing, go ahead and replace it by the framed version of n. And so this starts with the list. It looks at each element, and then it checks if it's prime. And if it is, then it will frame it. And if it's not going to change anything about it. So that's what that does. And you could ask Notebook Assistant for more explanation of any particular thing. And you can get pretty wild with the sorts of questions you ask here. So you've asked a good variety. Let's branch out to kind of another topic area. Let's say, how could I publish a web form where somebody types the name of, let's say, a chemical, common name, smiles string, maybe some chemists in the academic audience as well, and gets back a nice 3D plot of the molecule. Let's see if it can do this. A little trickier operation here, right? Okay. Seems reasonable. There's a form function. It's going to take a variable that we call chemical. It's going to be understood to be a string. We're going to make a molecule out of the chemical, and then make a molecule plot 3D. And then we could use cloud deploy on the form and set the permissions to public. In a lot of these cases, you could do something a little bit differently if you already know how to do it. For example, I know that there's a function cloud publish, which is basically just cloud deploy with the permissions automatically set to public, like you'd expect from the name cloud publish. The intuitive names strike yet again. So it didn't do that, but that's totally fine. This is a valid thing to do. We get an explanation for what each part does. Let's give it a shot. There's our cloud object. I'll pull this in. Let me type, let's see if it works. Let's type caffeine. And there is a 3D plot of caffeine ready to go. I mean, I have to say, you do have to learn a little bit to publish a web form in Wolfram language, but being able to just specify, quite demandingly, I want a web form where somebody types a chemical name and then they get a 3D plot of the chemical. Like that's a pretty surprising and wild thing to be able to just do just by asking for it. So I think that's a really good example of the namesake of this webinar. How do you turn a rough idea into something computable, something that just works? And here it is. There's your 3D thing. Maybe is dopamine, does that count? No, there it is. can see the 3D structure and everything. I have to say, pretty neat. I'm surprised. We're batting 100. That's always surprising when working with LLMs. You can ask kind of interfacial questions. Maybe you're making like a demo for something and you want to figure out how to, make a certain type of slider or something. Like you could say, how do I make a circular slider? And this is one way to do it. I think that's maybe a little bit complicated. And this is also a thing, when you work with LLMs, you can maybe get a sense of maybe ways that it could do something better. I mean, let's see if this works first before we criticize. Oh, well, that's pretty neat, I have to say. I'm going to say maybe there's a simpler way. Perhaps a built-in function. And there's you can see it actually wrote kind of the simple code first, and then it padded it out with some extra information there for us. So let's try this. The endpoints for the scale cannot be the same. Our first code that doesn't actually just work out of the box. So let's see here. The endpoints for the scale cannot be the same. Let's just toss that out. Okay. And then if we click on here, we can see this. Well, I think it should have a little, almost clock hand, gauge hand on it. And in most of these cases, you can go back and forth with the assistant and get it to do what you want. I'll see if this works here, and if it doesn't, I won't spend too much more time on it because I don't want to. Spend a lot of time just kind of discussing with this when I could be showing you other examples. But depending on your meaning, you can be a little more specific here. And one of the things I was able to, I think actually the first result I got last time I tried this, it's probably the best result I've seen from here, which is just this. I think that's nice. And you could ask it to change the scale to go, say, between 0 and 1 and so on, and change the color of the thing. So if you have some like graphics object, you can also modify it here. We did that by changing the color of the 3D elevation data around Mount Everest in K2. Well, let's try it here. In that last gauge, could you change the range to go between 0 and 1? Also, make the needle of the gauge black instead of red. And we'll see here if it thinks I'm referring to this or this. Hopefully this. Okay, that did not do that part. It did do the first part, but not that part. Yeah, I'll give it one more chance to get the gauge style right. Let's say indeed, gauge style, I think, is probably the way to go for this one. And there we go. Just a little prodding, and we're able to get it to do what we want there. Now, the time has really flown by. I can't believe we're 45 minutes in. Let me try some more examples here. I think show some really neat behavior. I think we've had plenty of those already, but let's do some more. Let's say, make me an image that has all of the planets arranged, let's say ordered by their respective numbers of moons. That requires a lot of kind of built-in information and understanding of what I'm asking about. It's using the evaluator, so it's writing code, running the code itself. Oh, and I forgot to show you the most important, obvious thing. If you're in a notebook and you have access to Notebook Assistant, the way you open it is you just click Help, Notebook Assistant Chat. That'd be a valuable thing, right? Probably somebody has asked that in the Q&A, but I have left the Q&A to Bradley and Luke, because if I look at the Q&A, I will never leave the Q&A. So that did not seem to work. Just give me an image, like a collage or a row, rather than a bar chart. Let's see. Yeah, this is sorted from greatest to least, and it's left off the ones that don't have any moons. I think my favorite result that is provided for a query like this was it made me this image, which I think was quite nice. Let me paste it in here. So it included the planets that have no moons. And we have one moon, there's two moons, and then some large number of moons. And when I first saw this, I thought, oh, this thing is hallucinating. It's saying that Saturn has a larger number of moons than Jupiter. That's crazy. But then I looked it up, and apparently they keep finding more moons. So Saturn actually it's in the lead currently. So it got that right. And I think if you, again, coax this a little bit, you can get it to produce something like this or a row like this. And here it has sized the images, I think, according to the number of moons as well, which is not something I asked for, but it's something you might be interested in. But I think with a little coaxing, you could get it to produce something like this again. You can ask for things like interactive demos, which I think is quite useful. So again, we'll point to our academic folks, maybe to our students. Make me an interactive demo that shows how, let's say, frequency, phase, and amplitude of a sine wave work. This is something I remember when I was a little baby. I didn't really understand what all the different parameters inside of a sine really did. And this would have been very nice to have at that time, I tell you that. So if we plot this, or if we just run this code, okay, that's what the amplitude does. This is what the phase does, and this is what the frequency does. Ain't that nice? And I wonder, here we go. wrinkly due to the high number of oscillations. Let's say, could you center the plot around 0, 0 and use a larger number of plot points so the plot is higher quality? Okay. Still writing. Let's insert and evaluate. I think going out to negative 2 pi and 2 pi is maybe a bit much. I'll make an executive decision here. We'll just do minus pi to pi. It still works, but you might want more plot points, takes more computation, etc. And you could ask it to adjust this. And here we've got this. Here's our lovely 3D plot, and we can see it in 3D what frequency does. Kind of maps in an understandable way to the 1D case, or I guess the 2D case if we're going to call this a 3D case. The surface itself is manifestly two-dimensional mathematically, and we can see exactly how all this stuff works. And just like for the mountain plot, we could ask it to add, a height-based color function if we want. But with 9 minutes left, I won't use our time to do that. You can ask questions about like geometry. So you could do something like construct a scene where, let's say a geometric scene, 3 circles intersecting at one point. Okay, so we can see here that there's an issue here. It's mixed up the brackets in a way that I think we could fix pretty easily, but that's pretty rare to see. It does happen now and again. And if you get into a case where it's kind of giving you stuff that doesn't quite work, it's producing errors, you can actually ask it to run the code before showing it to you to confirm that it works without errors first. Because it has the Wolfram Language Evaluator, or has access to that, it can do that and check that the code runs error-free. There really is so much stuff to show. Okay, will that work? Now that is pretty neat, I have to say. So you can move around these 3 points that are defining each circle, and then we can move around this point where they all intersect at one place. And that is pretty cool. You could do, there's all sorts of built-in stuff, and you can access all of it through here. So the number of examples I could show you is really, it's pretty limitless, and it's just a matter of figuring out what to try and show you. Okay, let's see if this works. Not quite. I know this is close to working. And if I look at the documentation for this, maybe I could see this works over the past week. maybe that's something that's not quite supported by this. Uh, Notice also a neat little thing here that when I said last month, it understood that I meant, today, and say subtract 30 days from today. And again, I think, according to the documentation there, I think all we have to do is just run this. So even if it doesn't get you quite what you want, again, if you just look at the documentation, that will usually get you there. And knowing where to start looking is, I'd say, half the battle, but it's probably more than half the battle. Okay, so there we get a rendered video that we can then play and see what the activity on the sun looked like over the last week. Not a lot there, but there it is. Now, again, there's a lot of stuff I could show you. I want to show you just a couple final examples that I thought were particularly interesting. So suppose I have my lovely boy who is currently sleeping on the desk next to the trackpad, behaving very well, looking very stupid. Say I've got this. I might say something like, convert my boy to a black and white image. And there we go. And it's kind of clarified here that by black and white, probably we mean like grayscale. When we talk about black and white movies, it doesn't mean that those movies only have the colors black and white. It just means that they exist in the grayscale color space. So here we can click in and we can see that it used color convert on my boy and just color converted to the grayscale space. Now I have in the past, when I've asked it a similar question, it has returned an actual binarized image that is literally black and white like I asked for. And something that I thought that was really cool is I said, oh no, I don't mean black and white. I mean like black and white like an old movie. And it understood when I said black and white, an old movie, that what I meant was something grayscale. And so I thought that that was a nice demonstration of contextual understanding. I might go a couple minutes over time here, but I do have to return to Neural Nets Bootcamp, so not more than 2 or 3 minutes. Something I was super impressed by. I was doing a little, hobbyist image analysis of the bottom of my espresso basket, this is a Pullman 876 basket. So I know how to do this, but I was just curious if Notebook Assistant could do it. So I said, I'm just going to paste in my query here so I don't waste the time typing up a long query. But I basically say, here's my thought process. I've kind of held the basket up in front of the sunlight so that each hole should correspond to a really bright spot. And I want to count the number of holes. And I basically say, how could I count the number of connected bright spots in this image? Okay, let's see if this works. And it suppressed the output. Let's unsuppress it. 877. And I told you that the basket is called a Pullman 876. Why is it called a Pullman 876? Because it has 876 holes in the bottom. So I have to say, that's pretty dang good. For reference, it says 877 because I failed to crop the image correctly up here, and there's another big bright spot that I didn't notice. But if you get rid of that, it does actually just give you 876. And I was like, wow, okay, that's pretty awesome. Two more examples. That's what I have time for. Another example. I have a demo for one of our courses, Notebooks as Instructional Tools, which aims to kind of show you how you can use Wolfram Notebooks in an instructional environment. And one of the workbooks that I show is an exploration of the Collatz conjecture. Now, we don't have to get too fancy about the explanation, but the idea is that the Collatz conjecture is start with a number. If it's even, divide it by 2. If it's odd, multiply it by 3 and add 1. The conjecture is that if you take this process, that is, you divide an even thing by 2 and you take an odd thing and you multiply it by 3 and add 1, if you keep doing this over and over and over and over, eventually, for any number you put in, you eventually get back to 1. And it's a conjecture because this is not actually proven. And it's an interesting and open conjecture because nobody knows any counterexamples. Nobody has ever found a number that it doesn't work for, but nobody's actually been able to prove that no matter what number you put in, it always returns 1. So this is just some code from that notebook. So what I said in this context was, I've given you some Collatz functions. Get all the Collatz sequences for integers up to 2000, break them up into lists of adjacent number pairs, convert each pair to a rule, get the list of rules, combine them into a big list, remove all the duplicates, and show me a graph. And I specify a couple other options there. The idea is that for every number, it has kind of a path through Collatz space, if you will, down to 1. And it's kind of fun to visualize these things. So I explained how I would think to go about visualizing them, even if I don't know how to do it code-wise. And let's see if it can do it. Okay. This is looking really good at first glance. Let's insert and evaluate. Boom. So here's a graph where it shows the connectedness between each integer in the Collatz sequence. So let's, I don't have any more time here really, but I asked it to put the labels of the numbers in the tooltips here. And so what will happen is if you mouse over these, you'll actually see how it follows the Collatz sequence. And eventually somewhere in here, there's a 1 and all of the paths lead to 1. And then do I have one last thing I want to show? Just one, maybe. Yeah, one last thing about Wolfram language programming. Say you're totally new to Wolfram language programming and you don't really know how to do functional programming yet. You don't have a sense of it. And you think, okay, well, I've got a horrible list. It's a 3 by 5 by 4 list of random numbers. And you might think, okay, if I've got a function f that I want to apply to all of those random numbers, what I've got to do is I got to make a new list of zeros that has the same dimensions, 3 by 5 by 4 as my original list. And then I got to write these totally nasty nested for loops where I make up these fake iterators that count the dimensions and then iterate. And I pull in, I do all this stuff. And then at the end, what I do is I put in my new list, f acting on the appropriate element of my horrible list, right? So what I would get in the end is my new list here, where f has acted on all the individual elements. You might say, I'm new to Wolfram language and don't know how to program functionally. Could you rewrite code that turned my horrible list into my new list in a more Wolfram way? Okay, and so it says, it gives us a definition here. I'm going to copy and paste this in. I don't want to define what f is. I'm just going to leave it undefined. It does comment and tell us that we should replace it with the actual definition. We don't need to in Wolfram language. It's fully symbolic. But here it is. In Wolfram language, instead of doing all this horrible looping nonsense where you have to count up everything and make a temporary fake array and make 3 iterator variables that you ought to clear later, you just say map it at level 3. And if we check the matrix form of this thing, it's the exact same list. You can then even ask follow-up questions. Suppose f is sine. Does that let me do this any more simply? And I, as a Wolfram language knower, happen to know that it does, so I can check whether this produces a good result. And so this actually explains directly that sine is a built-in function, and a lot of the built-in functions automatically apply themselves to each element of a list or array. And this approach is even more concise, and in fact, it's even more efficient. So here, it's just saying that sine will automatically work on this. So you don't need to do any of this stuff. You definitely don't need to loop, but you don't even need to do the map. You can just apply the function directly. So that's that for this talk.